everybody, and welcome. Thank you for joining today's session, where we're going to talk about the power of on-premise data warehouses in a cloud-first world. I'm Ian Stewart. I'm Product Marketing Director here at Exasol, and I'll be your host for the session today. Just wanted to say a few words really before we get started. I mean, for us, we're excited about bringing this content to you, keen to have a discussion around this, as we feel that today's topic couldn't be more relevant. As organizations navigate a cloud-first future, the role of on-premise and hybrid data architectures is evolving faster and more strategically than ever before. And to explore this today, I'm delighted to welcome Mike Ferguson, CEO of Intelligent Business Strategies, a recognized thought leader in data and analytics. Mike's going to walk us through key insights from his latest white paper, where he shares why on-premise data warehouses still play a critical role, particularly in regulated industries and high-performance environments. And then after Mike's talk, we're going to shift gears a little and give you a glimpse into how Exasol is accelerating AI and machine learning use cases within these environments, where Madeleine Connelly, one of Exasol's product experts for AI and ML, will share a short overview of some of the things and what's coming next. At the end of that, we're going to wrap up with a live Q&A. So feel free as you go through the sessions to submit questions using the Q&A box, and then we'll get to as many of those as we can at the end. We will also capture all of the questions and answers and send those out as an email shortly after the webinar as well, just to make sure everybody's captured that. And remind everybody at the end, but there are also mechanisms into our community forum where you can submit questions after the event if something comes to your mind. So without further ado, I'll hand over to Mike to start taking us through the content. Mike, over to you.
Thank you, Ian. I'll just share my screen here. Whoops. Get to the right slide. I hope everybody can see that. So, thanks everybody for taking time out of your busy schedules to join us today. So I'd like to talk to you about the power of on-premises data warehouses in a cloud-first world. A little bit about me, first of all. I'm an independent industry analyst and consultant based in Europe, focused on research, education, and consulting. So it's a great privilege to be with you today. If you want to know a bit more about me, I co-founded a company back in the 80s with a very famous individual, a Turing Award winner, Dr. Edgar F. Codd, who of course invented the relational model, which caused the birth of the relational databases and the SQL language and a data modeling technique called data normalization. And the other guy at the company was Chris Date, who wrote lots of books on introduction to database. And then I went on to Teradata to become chief architect on the product strategy and architecture team there, working on the first massively parallel database before starting my own business back in the early 90s and staying in data management and analytics. I'm also chairman of Big Data London. If you have ever been to that show, it's the largest data and analytics conference in the whole of Europe with over 20,000 delegates. Again, looking forward to that show again in September this year in London. Okay, let's get going. I want to look at, first of all, the kind of demand for data and AI, and even though there's demand there are still a lot of challenges kind of in the way of progress to maximizing business value from data and AI. And so I want to look at those challenges and then say, well, what about the future? What does that hold? And given those kind of future oriented kind of trends, if you like, then what are the kind of requirements if you're going to be kind of cloud smart in a data and AI driven enterprise? So let's take a look at that first of all then. So I think it's pretty clear today that the expectations amongst executives for data and AI are pretty huge. It's quite clear that I think it's, they expect it to give them automation and therefore greater speed and agility to be able to transform their businesses, give them competitive advantage to hopefully disrupt the markets that they compete in. But even though we're seeing significant benefits from data and AI, it really, really matters that we have a high quality governed data foundation. But if you look around at some of the surveys that are out there today, there's no doubt that we're seeing real evidence. This is a McKinsey survey done earlier this year, showing, looking back at 2024, showing that we started to see benefits on increasing revenue using generative AI, for example, in the first half of the year. But as you can see on the right-hand side, in the second half of the year, it was significantly greater increases. And I think expectations is that it's going to carry on in a positive direction. Similarly, same survey on the cost side, you're kind of reporting cost reductions from generative AI within business units. And again, you can see here things like supply chain and service operations and finance and HR are all already reporting cost reduction benefits from that. So very clear evidence already, and therefore real eagerness to adopt data and AI going forward. And again, a different survey, the PwC CEO survey, which is done annually at the beginning of the year, you can see executive expectations for this year are pretty high, higher than last year in terms of increasing profitability of organizations. So yes, there's great expectations. There's a lot of positivity around, but there's still several challenges in the way of maximizing value from all of this. So let's take a look at what those are. The first one is pretty clear. It's data complexity. We're now at a point where most organizations have got data stored in various data stores in multiple clouds, on premises, in software as a service applications, which could be running in the data centers of those particular vendors, and also streaming in from the edge. So I would say, therefore, we have a distributed data estate, and that's complex. So we're also seeing companies still with silos for analytical systems. What I mean by that is, data science, maybe building machine learning models, for example, using a data lake on cloud storage. We've got business analysts using data warehouse, classic data warehouse, which could be on premises or it could be in the cloud. We've got niche analytical areas like graph analytics, often very popular for things like fraud or cybercrime. On a graph database, to satisfy that, we might be doing real-time streaming analytics on live clickstream or financial markets data, or anything like that, in order to be able to quickly react and make recommendations and take automatic actions. But every one of these is siloed, and often multiple tools being used, different tools being used in each one of these silos to engineer data for a specific individual kind of analytical workload. And of course, with no standard to share metadata, very difficult for people in one silo to know what's going on in any other silo if different tools are being used in each of those. So that's not helping. So we're getting still point to point, if you like, analytical systems, sort of data engineering. People building pipelines for a single use case, if you like, for building a specific machine learning model for a data scientist. Other data scientists may be also building pipelines for their machine learning models. Same for graphs, same for populating data warehouses. And you kind of often see the same data, particularly master data, used in almost all of these workloads. So it kind of makes you ask the question, well, how many times are we extracting and transforming the same data for different analytical workloads, and what's the you know, that seems to be more like reinvention, and do we run the risk of inconsistently doing it for different analytical workloads? Also, the operating model for data engineering is changing. We've had historically centralized operating model where IT was tasked with doing all of this, building all of these pipelines on behalf of the business. But it's pretty clear now that we're at the point where so many data requests are coming in from different parts of the business that data engineering has been outpaced by the demand, especially as more data sources become available. And so the net result is that we have a bottleneck in IT, just outstripped by demand. So you could say, well, democratize it, but even that's caused problems if you create multiple data engineering teams around the enterprise who've bought multiple tools to build pipelines, and maybe those tools are using consumption-based pricing, and so we got lots of teams building pipelines out there, potentially on the cloud, no ability to share metadata or therefore to reuse things across those tools. And so there's big concerns there about, again, reinvention, inconsistency, costs, and so on. So just at this point, I'd like to kind of ask, maybe we could put up a couple of surveys here. The first survey would be, how many of you are kind of like, worried about the cost of data engineering and integration of data on the cloud, with the move to consumption-based pricing? I'm going to put that survey up.
We've got 67% voted yes, 11% voted no, and 22% not sure.
Okay, so quite a sizable majority concerned about that. So let's then put up the second of the two surveys, which is really about asking you, given that a lot of you are worried about this, then how many tools are you currently using to clean and transform and integrate data in your organization? Is it just one? Is it 1 to 5, 5 to 10, more than 10? Bearing in mind, data scientists are writing code in many cases to do this. So, we're talking about ETL tools, self-service data preparation tools. Maybe you're using workflows in drag and drop, tooling for data mining, data virtualization. I mean, there's lots of options here, but I just try to find out, well, how many tools you're currently using across your business, if you know, to integrate the data.
Okay, seems to have stabilized there. So we've got 13% with 1 only,
Right.
65% with 1 to 5, 18% with 6 to 10, and 6% with more than 10. The numbers are changing ever so slightly as last minute results come in.
So what it does show, though, is that quite a large number of you got 1 to 5. So there's certainly more than one out there, which of course, if they're all based on consumption-based pricing, is an interesting problem in terms of overall costs. The problem is if you just decentralize like this and let everybody go do their own thing with their own tools. We've been down this road before. 12 years ago when self-service data prep emerged, we did that. And, what happened was a Wild West. Ungoverned self-service data engineering, people grabbing data from all kinds of places, not really knowing who's doing what. And so, clearly governance and coordination of data engineering projects really matters. But if you're doing it across multiple tools, it's much more challenging to know that certain activities are going on in this area. And one of the quotes from one of my clients, when I did a review, the CDO came back and said, well, based upon the review, it looks like everybody's blindly integrating data with no attempt to share anything. Which, working in silos is a big deal. But if everybody's doing that, then, if you think you had more silos when I showed that chart before, now we're at a point where, as you can see, you could have lots of personal silos of everybody creating their own versions. And then you say, well, how many times is the same data being extracted and transformed? And there's absolutely no guarantee anyone's doing that consistently to get the same potential aggregations and whatnot that may be needed for certain calculations. And so yet again, there are challenges here. Is this going to result in inconsistency? Are we going to have multiple versions of the same data floating about? And if all of this is happening on the cloud, what's the cost of that? That's pretty scary. And there's other concerns as well. Heavily regulated industries very worried about compliance when it moving data to the cloud, given that we have multiple clouds out there for most organizations these days, especially with global companies operating in different legal jurisdictions. Big concerns about data sovereignty and moving data to the cloud outside of a jurisdiction, for example, or compliance with all of the legislation and regulations, whether they're regional specific like GDPR across the European Union, whether it's state specific like the California Consumer Privacy Act in the US, or vertical industry specific like HIPAA in healthcare. So all of these are still concerns. And another thing that's happened is with the emergence of generative AI, we now see lots of BI tools with natural language user interfaces. At the bottom of the chart, you can see here that what I certainly see is the impact in my clients, which is without natural language interfaces. BI tools had a fair number of users, but now that we've moved to just asking questions in text, or in some cases even voice, we're seeing this, large numbers of users now saying, oh, I can do that. That's easy enough. So big growth in the number of users making use of these tools. And so big concerns about whether your data warehouse or lakehouse is going to cope with a number of concurrent users. And it's not just the number of users that are growing rapidly by making use of this new user interface, but also we're now seeing a real explosion in the number of AI agents, and all of those are going to want access to the data as well. So you take the combination of the two, big concerns of concurrent user scalability on the underlying platforms. And of course, with all of these tools, accessing one or more data warehouses or lakehouses, the concern is, well, has everybody got the same data names and the same calculations happening? There's no semantic layer. So potentially people struggling with different names for the same data across multiple different data stores, inconsistent metrics and whatnot, can certainly cause uncertainty. But I don't want to be a purveyor of doom and gloom here. We're still seeing positive results out of all of this, but what does it mean? Well, in the future, I think what is clear is, data and AI is now fundamentally required to underpin every business function. It's not just one or two parts of the business. Every part of the business now wants it. We're seeing rapid growth in natural language queries and AI agents and machine learning models. Tools to build AI agents are popping up everywhere. Going to see lots of those in the enterprise going forward. And also the cost of compute with respect to AI is increasing. And with conversational analytics through natural language interfaces and AI agents as well, all of those are going to get integrated into apps, which is even more people using them through through the applications that they're using. So I think we should expect concurrent users of analytical databases to skyrocket. And we're going to see democratization of data engineering, which means far more pipelines, But then the cost of democratized data engineering, if everybody's doing this in multiple tools on the cloud with consumption-based pricing, it's just unknown. I can't see how any CFO knows what the invoice is going to be like in that situation to see across all of those tools and all of those pipelines. And of course, more agentic workflows and more legislation and regs as well. So setting all of that, looking at all of that, what are the requirements going forward? Well, there's sort of different categories here, sort of fundamental requirements, scalability requirements, performance requirements, architecture, governance, etc. On the fundamental requirements, I think, with the concern about costs, I think several companies are now looking at should they repatriate some of these workloads back on premises again to put a lid on the costs and keep a handle on that. And certainly data engineering that's based on consumption-based pricing is certainly a candidate for that. If people are concerned and not sure how many records they're processing with all of these pipelines out there, bearing in mind that consumption-based pricing works on that basis. So yeah, with all these teams, how much data, how much money could you save if you repatriated some of the data engineering workloads back on premises rather than everybody running lots of pipelines on consumption-based pricing, and that means based upon the number of records and all the data sources that they're connected to and transforming and integrating. But if we're going to do that, then of course the on-premises data warehouse, if you're going to repatriate, is going to have to scale because it's going to be taking a lot more ELT workloads, using SQL to transform the data. So we really need things like columnar compressed storage. We need partitioning, clustering, parallel processing. All really matters to be able to go and produce run those pipelines and build data products. So we kind of want all those kind of capabilities that I mentioned, and dynamic workload, automatic performance optimization and automatic tuning there to be able to dynamically reallocate resources if necessary and isolate workloads so that they don't bump into each other. To be able to do that on premises data warehouses for performance as well as even on a lakehouse environment, and ultimately building a data products which could be on a data warehouse to be able to share across multiple analytical engines. We give different virtual views of that to allow those data products to be joined to, for different analytical needs for business analysts on a data warehouse environment, or data scientists in using something like Spark and Python, for example, and even being able to stream data into that environment. But quite clearly, we're going to need a lot of concurrent users on here and be able to support significant increase in pipeline processing running in this environment as well. Similarly, if you were to do it on the cloud, you would still want to accelerate this if we're doing it all in a lakehouse environment on cloud storage, for example, with open tables. You'd probably still want to accelerate concurrent usage on top of that to be able to make sure that all of those agents, all of those users using natural language queries can get the performance that they need on top of that environment as well. So we really kind of need, to put our foot on the accelerator pedal here in terms of database technology that's going to handle that. And also to be able to deal with compliance requirements, things like in database anonymization and access control at the row and attribute level, and being able to support data sovereignty by minimizing the need to copy data outside of the jurisdiction. Also, you need to be able to support, if you like, all of these workloads. Whether it's a growing number of agents, more and more users on the BI tools, as well as classic data science as well, to be able to run in database machine learning, high performance SQL, and also invoking GPUs invoking large language models on GPUs that could run outside the database um, in order to satisfy generative AI kind of requests. So not only do we need to do that, if you like, on an on-premises data warehouse and have that capability, but if you were going to stay on a cloud to be able to do this, you still need to want to look at it. Could you, you know, have perhaps in-memory parallel processing on top of a lakehouse in order to accelerate that as well to support the concurrent usage going on. And of course, we mentioned the semantic layer. Is it possible to put a semantic layer between all the tools in order and the underlying data to make sure everybody's consistent with common data names and calculations and whatnot? And of course, this could be provided by the data warehouse platform if it supports virtual schemas to make that possible, to connect to multiple data sources outside the warehouse as well as have data in the warehouse. So to conclude then, I guess what I'm sort of saying is that I think data and AI is now critical for pretty well every part of the business to support decision making on the one side and task automation to help reduce costs and improve efficiencies on the other. I think generative AI is really making it possible for people to start now saying the new user interface is natural language. But the side effect, if you like, of that is that far more people will find it easy to use these kinds of tools. And so we're going to need to scale to handle big increase in concurrent users, both in terms of human users and, of course, AI agents going forward. And if we democratize data engineering, then all of those pipelines are going to see far more of those. And we need to be able to manage the cost of democratized data engineering while protecting data sovereignty and sensitive data and whatnot. And you may want to consider repatriation of some of those in order to lower those costs and keep a lid on them rather than just not knowing what the invoice is going to be like at the end of the month. And then we can then produce data products with those data engineering pipelines on platforms that can support multiple analytical workloads so that we can support business analysts and data scientists and whatnot without necessarily copying the data. And if you do have a legacy kind of data warehouse on premises and you are going to repatriate workloads, then you may want to look at upgrading that in order to accelerate it to support those workloads on top of what's already running there. So I hope that gives you an idea. And with that, I'll pass it over.
Thanks, Mike. I think that's such an incredibly comprehensive overview of really the just massive level of requirements that we have for our data platforms, and we keep adding kind of like more requirements that we need to them. And I think you did a really good job of kind of bringing those together, both in what we need from a data platform today, and also the fact that those data platforms are kind of actively needing to scale for the needs of tomorrow and the future with regards to AI. And so I appreciate both of those perspectives, and it just puts into view just kind of the breadth of what we need to plan for. So I'm going to kind of try to respond to some of those needs. And we're talking about this in the context of Exasol. And we're also talking about this in the context of Exasol as a data platform that operates in both an on-premise, a hybrid, and a cloud world. And while that might kind of seem surprising to some folks, I came from several companies before this that were very much cloud first and SaaS first. And so why do we talk about on-premise? Why do we talk about these hybrid workflows and these hybrid platforms? And there's some key elements to that. The first, of course, is flexibility and choice, right? You should be able to put your data platform where your data is, and it should meet your business needs. But also, where you operate and how you operate has a big impact on the performance you can give to users as a data platform, and also the cost that you can give to users. So really looking at that cost to price and performance kind of trade-offs and ratios. So I'm going to try to talk about all of that today, and we've got plenty to cover. So let's dive right in, and hopefully we have some good ideas and discussion. And as always, please feel free to throw any comments or questions in the chat. I think some folks have already been doing that. Let's dive in. So again, I'm coming at this from an Exasol perspective. So let's start with an overview of the Exasol platform. And we talk about Exasol essentially as an analytics engine. And so there's a lot of different ways you can bring Exasol into your environment. And I like to look at it through the lens of use cases. And there's some key use cases that we see Exasol unlocking for our users. The first is pure acceleration. Exasol is really built around high performance. So if you need those hyper fast queries, whether it's one query that needs to be really fast or that scale query. So if you have tons of users, high concurrency, high volume, we also scale and deliver high performance at that level. So just thinking about acceleration and where that's needed. And of course, modernizing. So we work with lots of customers that are trying to uplift their data platforms, modernize those, make them more scalable, make them more integrative, and really kind of bring them forward into the future and plan for those forward-looking use cases. I'm going to talk about optimization today as well, because like I said already, that's a huge component of this. How do we deliver high performance at a reasonable cost that you can also predict and plan for? And then governance is really at the heart of all this. And that's where the power of the on-premise database really shows, is you can get all of the above and you can deploy in an environment that works for you. So I want to dig into these a little bit more. And behind the use cases, we kind of see these challenges and pain points as common themes that we see amongst our users and we see in the industry in general. And Mike alluded to all of these. So the first is exploding compute costs. And we just see this across the board, which is just more and more compute required to meet the needs of users, meet the needs of analytics, and also just to meet the needs of data pipelines and data platforms. And this leads to unpredictability. This leads to that, massive cloud bill that you weren't expecting. And there are lots of different controls that people are putting into place. But of course, those are all reactive to the fact that this is still a huge challenge. Then we have regulatory and internal compliance. And this is, may seem dry to folks, but the reality is we're all living in this world, right? And we all need to plan for the security of our data and the security of our users and meet whatever requirements we have, whether those are industry specific, nation specific, things like GDPR. We all want to rise to meet those requirements and be ready to meet new requirements as well. And so that's where platform flexibility is really a requirement. And I'm going to keep hitting this point about performance. And another way to look at it is in-time delivery of the right data. So getting the right data when you need it. So let's zoom in a little bit and think about how Exasol fits as a data platform into your broader data stack. And whenever you talk about a data platform, it kind of becomes a story about not just the tool itself, but everything around the tool. And so Exasol's story is one of interoperability. So bringing together data from lots of different locations and making it available and usable in lots of different places. So at the bottom here, we see our data foundation. So this is our data where our sort of key data sources live. And we're seeing tons of kind of growth in this area. And so we support sort of your core raw files, your data lake files, as well as your data lakehouse files. And so things like Iceberg and Delta tables, we're seeing lots of growth there. And the great thing about Exasol is you can ingest all of this data, and then you benefit from the hyper performance of Exasol as that analytics engine. Then, of course, you can also access your raw storage, things like your cloud storage and your on-prem solid SSD storage. So you start to see that on-prem and hybrid story come into play. Basically, wherever your data is, you can access it via Exasol and then benefit from that high performance query engine. Now, Exasol also integrates very seamlessly with other parts of your existing data platform. So we have virtual schemas that you can connect to Snowflake, to Databricks, pick your platform essentially. And so that way you don't ever really have to do a full rip and replace. Exasol is very much cooperative with your other data components. And I see plenty of customers that have multiple data stacks just because of the different needs of users. And while that does create complexity, we just want to acknowledge that that's the reality of the world we're living in. And then on the top here, you see our interface layer. Now, of course, the analytics front, things like Power BI, Tableau, we have native integrations for those with Exasol, and that's pretty standard. But we're starting to see more and more programmatic interactions with Exasol and with data platforms as a whole. And there's sort of the programmatic, but really this should probably start to say data science, data engineering, and AI. And then eventually we're going to start to see this say agentic, right? And so Mike talked about this. We're going to start to see more and more interactions hitting databases, hitting data platforms, not necessarily from users, but from tools that users are leveraging, and also agents and AI workflows. And that's just going to increase the need for that high performance, that high concurrency, so that you ensure that you continue to get the results you need in the time that you expect them as your requests continue to grow. And that all brings us back to Exasol as the core, which is how do we continue to deliver that high performance, high scale with all of the data coming in from your various sources and all of the requests and access coming in from your different users at the front end. All right, I want to get into performance pretty early on here just because it's such a critical piece of how we build Exasol, truly. And so first of all, let's just talk about some pure numbers here. So we run plenty of benchmarking tests here at Exasol. I'm going to talk about that a little bit more, but let's kind of measure up Exasol against some of our key competitors and friendly competition, right? I already laid out that we can connect to data in these systems, and I have plenty of customers that are using a mixture of these data platforms and others. But the reality is Exasol is the fastest analytics engine on the market. And so here's a TPCH benchmark we did. This is 10 concurrent users, 10 terabytes. The results were 7 times faster than Redshift and 14 times faster than Snowflake. So that's on comparable hardware. Now, when it comes to pricing, and I'm going to talk about pricing a little bit more in a few later slides, you actually end up seeing Exasol being more than 6 times more cost effective than Redshift. So you get that higher performance and it's at a cheaper cost because of how our pricing breaks down. And you also see that Exasol is 13 times more cost effective than Snowflake. So the amount of compute that you need to be able to match Exasol is going to cost significantly more on these other cloud platforms. So to put it simply, you can spend less and get better results when you use Exasol. And these results scale, which I think is really incredible. So we also run these benchmarks at much higher levels of concurrency. And so this is based off of dashboard loading tests that we did. So complex dashboard with a 10-second SLA, which arguably is way too long for any dashboard to load. But it's a very beefy dashboard. And unfortunately, most of us have probably been in a situation where a dashboard does take 10 seconds to load. And so we ran this not just for one person loading this dashboard, but for 100 concurrent loads and then for 200 concurrent loads. And at that scale, Exasol continued to measure up. So at 100 concurrency, that's 100 concurrent users, 100 people hitting that dashboard and loading it, 7 times faster than Redshift. And at 200 concurrency, almost 5 times faster than Redshift. Now that's actually compared to Redshift still operating at concurrency 100. So now if we go even deeper, and if we turn on caching, we can see that those results get even better. And so this is load time when you use smart caching in Exasol, which is a really incredible feature that just gives you that added boost in terms of loading your dashboards or generating your queries. And so the reality here is, we got a lot of numbers on the screen, but Exasol at the end of the day, not only is it fast, but that speed scales with you. And so we heard Mike talk about how important concurrency is and how we're just going to see more and more users or more and more user-like access. So think agentic access, think programmatic access. You need to plan not just for the one user, not just for the 10 users, but for high concurrency use cases. So you need a platform that's going to scale with you. There's a lot of text on here, but you can look at the numbers on this screen. I told you we build performance into the database, and that doesn't mean just TPCH, TPC-DS benchmarking. It means we test Exasol's performance every day as we're building it. So we've executed over 100,000 tests in the last year. We have almost 240 unique tests that we run Exasol against internally. We have tons of test code, tons of server hours that all go in the back end towards these consistent tests that we run on our own software to make sure that what we're shipping is the best possible performance we can be delivering. And so we build performance into the database, and we constantly are measuring ourselves against our own sort of benchmarks. How can we be better? How can we be faster? It's a lot to talk about with performance, so let's distill it down. What does performance actually get you? Maintaining performance at high concurrency is critical, and we've now hit that point several times. When you build a dashboard, once you publish it, it's not just you looking at it. And more often than not, the issue when it comes to that slow loading dashboard is you've pulled it up in an MBR or a QBR and you've got 20, 40, 100 people trying to look at it at once. That's where you really start to see performance become critical. We need to plan for those high concurrency workloads. Also, performance that you can trust and rely on means fewer workarounds. So Micah talked about this a bunch. We have kind of all of these different data stacks that get spun up. And often the reason for that is there's a pain point or there's a problem where there's friction with the current stack. And more often than not, that is because of performance. So if your data stack performs, you are less likely to have people spin up workarounds to kind of get to a different level of performance and kind of sneak around that because you can rely on that main system. And so performance actually helps reduce complexity. And then performance means faster iteration. So it means more effective developers, more effective analysts. Think of when you're building a dashboard. If you have to wait 5 to 10 seconds every time you make a change, that is significant time lost. Now imagine that every analyst on all of your teams is waiting 5 to 10 seconds every time they change one thing about a dashboard. If you look at the scale factor there, it's huge. And so any performance we can save scales across your entire team. Performance matters. Now, I talked about pricing at the beginning, but I said I was going to dive into it in a little bit more detail. So let's talk about that. And Mike talked about compute pricing. Now, compute pricing is, I think, I don't want to say it's a bad pricing model. I think that there's room for multiple pricing models, and I think there's the right pricing model for the job. Now, the reality is compute pricing, when it kind of came into being with the cloud, opened up a lot of doors, right? It made it feel that the cloud was accessible and made you feel like you weren't paying for something that you weren't using. Now, unfortunately, what we've seen for lots of users is that has turned into a negative because that pricing is unpredictable. And more often than not, people are getting surprised by that large compute bill because they weren't able to predict how much usage they were going to have. And even worse than that, what I've seen this do is I've seen compute pricing disincentivize analytics and exploration. It makes developers afraid to issue that hefty query, or afraid to build that more complex or more nuanced dashboard, or afraid to do that deeper data exploration because they don't know how much it's going to cost. And we never ever want to create a situation where our analysts aren't able to do their job or are afraid to dig deeper into data. That's a huge risk. So this is where fixed pricing or data volume-based pricing, which is the pricing model that Exasol uses, becomes critical. And in large part, we're able to provide this level of pricing because of our on-prem and self-hosted models. So, or model, I should say, deployment patterns. So because a user can deploy and pay for the hardware themselves or have their own hardware and control the costs in that way, we also give them control over the Exasol license. So that is one fixed cost, and that means you can always predict what you're going to pay. So that encourages adoption and it encourages deeper analytics. It provides consistency for your cost centers, for your finance team, and you can plan for steady data volume growth instead of trying to anticipate wildly fluctuating compute costs based off of usage. So there's a place for both. I think they both need to exist because there's going to be use cases for each of these, but we don't need to be locked into this uncertainty that's tied to compute-based pricing. So I think there's a compelling story here about finding the right pricing model for you and for your use case. Awesome. All right, we're shifting right along here. And the next thing I want to talk about is semantic layers. And Mike talked about why these are so important. And I want to make a distinction between semantic layers and data catalogs because we hear about those a lot in kind of the industry, and they get used in similar ways, but they are different. A semantic layer, this word semantic here, meaning, the true meaning of your metrics, is really critical. And I think about this a lot. I think I had a project in a previous role. We were trying to do analysis on, I think it was SQLs or MQLs, sales generated leads, market qualified leads. And it turns out almost every department had a different definition for what each of those metrics was. And they had documented, they had written it down in their Confluence page or their Google Doc or whatever, but there was no consistent definition, which meant when we went into the actual data, there was no consistency in how we actually tracked those metrics. And that meant that we couldn't have metrics, we couldn't have KPIs because we didn't actually know what we were measuring, and we were all measuring different things. And so that challenge is true, and I think we've all probably experienced it. So semantic layers give us this unified business logic. It tells us, what does this metric actually mean? And that's super critical. Now, it's different from a data catalog because a data catalog tells you what's in your data ecosystem, what's available in your data platform, what's all of the stuff that you have access to. And a semantic layer tells you this is what it means. Now, having that shared business logic means that you can get to accelerated insights. So that project that I mentioned, where we couldn't figure out what SQL and MQL meant across all of the departments, we spent weeks working on a shared definition. None of that time was spent on analytics. That's time lost. Now we spend that time, we build that shared definition, great, but now we need a way to carry that forward. We also want to be able to layer governance and trust on that. And so having that shared definition means, hey, this person should have access to this metric or this person shouldn't. And then this is also going to build a foundation for agentic workflows. So as we start to see, LLMs, chatbots, and then general, like I would say not general, but more advanced agentic systems, that semantic context is going to be incredibly important. So how does an agent know what an SQL is? Or let's take it another way. Let's say you come in and you ask, how many leads did I generate last quarter? Does that mean sales qualified leads, marketing qualified leads? I'm going deep in the leads territory here just because it's, I think, a pretty relevant example. But you could look at that a different way. Let's say you have a non-technical user interacting with an AI agent, and they ask, what were my sales last year? What does last year mean? Does that mean calendar year? Does it mean fiscal year? Does it mean year to date? And what does sales mean? Does it mean regional sales, total sales, sales adjusted? You can see where that complexity starts to come in. So it all brings it back to having a unified definition, and that's where we store that in a semantic layer. So Exasol actually has a semantic layer, and we have a partner that built our semantic layer and implements it. And you can this is sort of a visual representation, right? We've got our star schema of what this looks like. But if you look on the right, you can see the true representation of the data, right? You've got your fact tables, your dimension tables. You can see the field names here are not the most user-friendly. You've got lots of ID fields, you've got order date, sales amount. You can kind of navigate that, but you can see between the fact tables and the dimension tables, it's not necessarily clear how it actually get, as a non-technical user, how I would actually get the true value. Then if you look over on the left, you can see our virtual table where we've created the true semantic representation of our data. Now it's easy for me to look at that as a user and say, oh, I want customer name. Oh, I want order number. Oh, I want sales, or I want purchase price. So we've created that one layer that abstracts away the complexity of the underlying data and makes it much easier to use that as an end user. Now, what the Exasol semantic layer does is it kind of functions as a translation layer between the query that I, as a non-technical user, would write and the actual query that gets generated under the hood. And one of the coolest parts here is that the semantic layer takes care of not just the meaning, but also the joins. How do we actually build out, based off of our facts and our dimensions tables, the actual joins necessary to give the metric that's being looked for? And so we don't necessarily want to trust every user with the responsibility of creating those complex joins, so we bake that into the semantic layer. Now we have customers using this semantic layer today. This is available on our website. You can always dive in deeper to see more about how our customer Auto is using the semantic layer. But let's focus on this 90% reduction in code complexity. This just drastically simplified the implementation, the usage of data within this organization. It meant it was easier to create SQL, and it also decreased dependence on IT. So analysts were able to move much faster. But another key point of this is that it increased trust as well. And so analysts actually were able to trust the data that they were accessing. So it reduces overhead on IT. There's less troubleshooting. There's less, hey, go fix this SQL command for me or help me write this complex SQL function. And analysts get to focus on the work that they want to do, and IT gets to focus on the work that they need to do. So we really just see a ton of benefit when we start implementing these semantic layers. All right. Now, the world of AI, there's plenty to talk about, and we've only got a couple minutes, so I'm gonna try to scratch the surface here. But I want to kind of reinforce. We've talked about a lot already, and we're still talking about the power of data platforms in a multifaceted world. So not just cloud first, but also addressing those hybrid and on-prem scenarios. And again, you can deploy Exasol anywhere. You can deploy it in the cloud. You can deploy it. We have a SaaS solution, but also I would say the majority of our customers are self-deployed. So even in either their private cloud or on their own hardware. And that extends to our AI story. And so built into our AI story is the same thing that's built into the overall Exasol story, which is that flexibility and that control that you need from your data platform. So before I dive into AI, let me set the stage a little bit. I'm going to talk about a couple pieces here. The first is a specific solution that we've built at Exasol to solve a pretty ubiquitous data challenge. And then I'm going to zoom out and talk about kind of how we're building or architecting our Exasol platform for future AI investment. Now, why am I starting with a specific solution? And the reason for that is I've worked now with a lot of different customers that are in various stages of AI implementation. And what I've observed is often AI is a solution in search of a problem. Now, there's plenty of wonderful examples of how AI can be applied to provide value to organizations. But I still see kind of a challenge there. And there's data to back this up. So we see only about 30% of AI projects actually make it into production stage and actually get to deliver value to organizations. So there's lots of different things being tried out in the market, but not all of those things are actually leading to valuable projects and solutions. So for Exasol, we decided, let's actually make AI tangible. Let's figure out how we can deliver AI to our users in a way that actually provides value. And so we wanted to solve a pretty ubiquitous problem in the data community. And that's the problem of unstructured data. So only about 20% of enterprise data is actually structured, relational data that you can use for analysis. The majority of enterprise data is unstructured, so upwards of 80%. Things like text files, PDFs, log files, tons of JSON, CSV floating around, and then other things like product manuals and scanned documents, but also things like consumer reviews and conversation logs. Just think of all of the like unstructured or semi-structured data that's floating around in your data lake in S3 on your local machines that's just sitting there, not really providing value. It's because this data is difficult to analyze. It doesn't have a relational structure. And we believe that AI is exactly the right tool to unlock the value of that unstructured data. So here's a pretty basic example. Let's take a support ticket. This is fake data, by the way, so no actual harm intended to any of the products mentioned here, all falsified. But support tickets are a great example of this application. And so you have a description of what's going wrong. The user explains, hey, this product is broken, or I'm having this problem with this product, or I'm missing this feature. Now, actually extracting that information is incredibly difficult because you have to know what you're looking for. Now, AI can solve that problem for us. So we can point a language model at our support ticket data here, at that just raw text input, and we can tell the language model to extract key pieces of information. So things like entities, things like keywords, things like topics. And we're able to do that. We can pull out things like what product had an issue, how severe was that issue, how unhappy with the experience is the user. All of that starts to turn into relational information and relational data that we can use. So we baked this process into a product that we're calling Exasol Text AI, and it's applying language models to extract insight from unstructured data. And it sets you up to actually do deeper analysis. So what's going on my unstructured data? What are the most common products that people are talking about in their support tickets? What are the most common elements people are discussing in product reviews? What's the sentiment behind those? What are some of the most recurring issues that show up in my product logs? Can I digitize some of my product manuals or my user manuals and pull out key terms? You can start to see over and over again all of the different applications of this solution. So that's one of the things we're working on when it comes to AI. And like I said, this is delivered as a specific product, Exasol Text AI, that extends the Exasol platform. But that's really just the beginning, because we have a ton more coming when it comes to our AI story, a full platform level sort of uplift of Exasol. And most of this is already available today, which is fantastic. And so when it comes to the world of AI, you can do a ton with Exasol, which means you can do a ton with your on-premise and your hybrid solutions. One of the things I'll call out is when it comes to language models, Exasol allows you to run language models directly within the database or to access self-hosted or third-party language models. So you can call out to your OpenAIs, your Mistral, your Anthropics, or you can integrate with your self-hosted models as well. So if you're looking at platforms like Cohere, for example, or if you're using Studio VLLM, you can access those self-hosted language models within Exasol. And you can even run language models directly within the Exasol engine, which is fantastic. Now we have tons of customers already using RAI. I'm going to kind of go pretty quickly through this one because I know we're getting close to time. But we've just seen a really high scale factor for what we can see with Exasol and AI. All right. And Ian, am I going to get are you going to play me off?
I've come on, yes. I was
Yeah,
just
go
going to
for it.
say, I mean, fantastic insight both from Mike and from Madeline. I'm just very conscious of everybody's time. I mean, I think as everybody's can see and hear, huge amount of passion, huge topics, way more than we could attempt to cover fully in an hour. So I think that if we draw to a close today, I think we've got some great questions. As I said at the start, we give us 24 hours or so. We'll send everybody an email with the Q&A, just so you've got that information. If, as we finish the webinar, for those that are watching, think of any other questions, please do email us directly. There's also, we're very keen to encourage all of you to help us really drive this our engagement through our community forum, which we recently introduced. We see that as a really powerful environment to help us learn together. So we're keen to any questions you've got, feel free to shout there. Equally, if you haven't done already, if you're not an Exasol user, you can download a free version of our community edition. You see the links here. Follow the QR codes, And also, if you haven't done already, really urge you to access with the link here and download Mike's white paper. And it's a chance of Mike to go into more of the detail that he spoke to. So I think we'd like to thank you all again. Thanks for everybody who participated. We'll send out some follow-up information. And thanks again to the speakers. Some great insights. Great to hear. Look forward to hearing more. Thanks, everybody. Have a good day.